Hello everyone. In this video, we are going to talk about Lewis structures in compounds. Lewis structure contain elemental symbols and dots showing bonding between atoms or ions. So we have for carbon tetrachloride, ammonia, and ozone. Some compounds follow the octet rule in their Lewis structure, meaning that they have 8 valence electrons, and some do not. Either they have odd number of electrons, less than 8 or more than 8 electrons. There are 5 steps to be followed to formulate the Lewis structure. So first we need to count the total number of valence electrons. Second, we need to draw a skeleton structure. This by forming a single bond between the elements and the compounds. 3 is we need to distribute the remaining electrons to the terminal atoms. 4, we need to place remaining electrons at the center atom. 5, we need to rearrange electrons to have double and triple bonds to obtain octets whenever possible. Okay, let's start with compounds that follow the octet rule. In this statement, we have NASA's Cassini-Huygens detected a large toxic cloud of hydrogen cyanide, HCN, on Titan, one of Saturn's moon. Titan also contains acetylene, which is used for plastic production. So let's try to examine the Lewis structure of these compounds. So before going into the steps, I have here the list of valence electrons for the elements that I will going to use, and also their electron negativity values. So let's start with HCN hydrogen cyanide. Step 1, we count the total number of valence electrons. And so we have hydrogen with 1 valence electron, and we have to multiply that with how many atoms it has in the compound. So you have here 1 atom of hydrogen, so that will give us 1 electron. For carbon, it has 4 valence electrons multiplied by 1 atom in the compound, so you have 4 electrons. For nitrogen, we have 5 valence electrons times 1 atom in the compound, so you have 5 electrons, and that will give us a total of 10 electrons. Step 2, we have the skeleton, and this is by forming single bonds between these atoms. And now we have carbon as our central atom here. A way of determining the central atom is to look at the electronegativity values. The least electronegative element will be the central atom. Hydrogen supposedly is our central atom, but hydrogen cannot be a central atom as it can only accommodate 1 element for a bonding. So let's go to the next less electronegative, which is the carbon. And so we have this structure here. Carbon is our central atom. So by forming this structure, we already accommodate 4 electrons. Step 3, we need to distribute the electrons to terminal atoms. Hydrogen can only accommodate 2 electrons. So we distribute the 6 remaining electrons on nitrogen. Step 4, the remaining electrons on central atom, and since there is no remaining electron, and this is our structure in step 4. And step 5, we need to rearrange these electrons to form octets in each atoms. And you can see that 4 of the electrons of nitrogen is being shared here with carbon. And so we have 3 single bonds between carbon and nitrogen. This will give us 6 electrons here and another 2 electrons. So we have 8 electrons for carbon. We have 6 plus a lone pair here, which has 2 electrons. So we have also 8 electrons for nitrogen, thus forming a really stable compound. And this is now our final Lewis structure. Let's go to acetylene. So step 1, we counted the total number of electrons and we come up with 10 electrons. Step 2, we have the skeleton. Step 3 and 4, distribute the electrons to terminal atoms. And this is now our final Lewis structure. And again, we follow the octet rule. Let's go for non-octet formation. And we specifically focus on the compounds that has odd electrons. So reading the statement, a methyl group is an alkyl derived from methane, containing 1 carbon atom bonded to 3 hydrogen atoms. Form of this compound are highly reactive and rarely observed. For a second compound, we have nitrogen dioxide. Is a reddish-brown gas above 21.2 degrees Celsius, with a pungent, acrid odor. Becomes a yellowish-brown liquid below 21.2 degrees Celsius, and converts to the colorless dinitrogen tetroxide below 11.2 degrees Celsius. So this is a very interesting compound. So let's also examine the Lewis structure of nitrogen dioxide, which is the formula NO2. For CH3, we have the total number of valence electrons. Forming the skeleton, we have something that looks like this. Step 3, this does not apply because H cannot accommodate electron anymore. So the remaining electron is placed on central atom C. And this is now final Lewis structure. We have an electron here that is alone. For nitrogen dioxide, we have a total of 17 valence electrons. Step 2, we have something that looks like this. Step 3, we need to distribute the electron to terminal atoms. And so we place that to our central atom, which is N here. And step 5, we try to rearrange those electrons to form octets, but this is a result. And as we can see, we did not form the octets, but rather this form. This symbol means that they are in resonance, meaning that this form is just equal to this form. This is our final structure, and nitrogen has an electron that is left unpaired here. And that's it, guys. Thank you so much for listening. Stay safe and may God bless us all. These are the sources for my presentation.
And these are my sources.
Okay, final na to.